Hi, in today's video we'll be revisiting and re-looking at the laws of indices for multiplying, dividing brackets, okay, and some harder questions relating to the laws of indices. We're going to start with question number 1a. Is this simplify m to the power of 5 times m cubed? Well, if I have what we call the same bases, i.e. the same letters or the same numbers times together, I just add the powers. So 5 plus 3 is 8. Okay, so the answer is m to the power of 8. Okay, 5 plus 3 is equal to 8. Okay, so it's m to the power of 8. This is part B. Okay, simplify m to the 8 divided by m squared. Well, if we're dividing and it's the same base, I subtract the powers. So it's going to be 8 take away 2, which is equal to 6. Okay, so it's m to the power of 6. Okay. This is part C. Simplify m cubed all squared. Well, if I have a bracket raised to a power, I just multiply the powers. Okay, so this is only true if I have a bracket raised to a power. M3 times 2 equals m to the 6. Okay, m to the power of 6. Okay, because I've got m cubed times m cubed. If you square something, it's the same as timesing it by itself. Same as saying m cubed times m cubed. And then it becomes exactly like a question in part A, where I can just add the powers. 3 plus 3 gives me 6. Okay. But this rule does obviously confirm my answer. Okay, this is question number 2. Simplify m to the 9 times m all divided by m to the 5. Well, here I've got an invisible 1 here. Okay, so on the numerator, I'm going to have m to the 9 plus 1, which is 10. So it's m to the 10 divided by m to the 5. Okay, remember that fraction means a division. I take away the powers, so it's m to the 5. Okay, so m to the power of 5. Okay. This is question number 3, guys, part A. Simplify w to the 4 times w to the 4 while adding the powers. 4 plus 4 is 8. So it's w to the power of 8. Same basis, I just add the powers. Part B, simplify a to the 6 divided by a to the power of 3. Well, I subtract the powers. So it's a to the 6 take away 3, which is 3. Okay, so it's a cubed. Okay, so the workings out for this one will be a to the 6 take away 3. Okay, and then this one, okay, conversely would be w to the 4 plus 4. Okay, I'm putting my full workings here so you can refer to it, okay, if you re-watch this video, okay. Question number 4. Match the expressions. Okay, c to the power of 10 divided by c to the power of 5. Well, I'll subtract the powers. 10 take away 5 is 5, so it's c to the 5. This one, c to the 7 times c to the 3. Well, 7 plus 3 is 10, so it's c to the 10. This one, c to the 8 all squared. Well, I do 8 times 2, which is 16, so it's c to the 16. And this one is c to the 6 divided by c to the 4. I'm dividing, so I subtract the powers. 6 take away 4 is 2. Okay, this is only true if I have the same base. If I'm timesing with the same base, I add the powers. If I'm dividing with the same base, I subtract the powers. If it's not the same base, then I can't simplify it by writing it as a combined power. Okay, I can't do that. This is question number 5. Simplify the following. S to the 3 times s to the 4 all over s squared. Well, on the numerator, I'm going to have 3 plus 4, which is 7. So it's s to the 7 over s squared. Okay. 7 take away 2 is 5. So it's s to the power of 5. Okay. This is number 6, guys, part A. Simplify w to the power of 3 times w to the 5. So again, I'm going to add the powers, but I've got to be very careful here. I'm doing 3 plus negative 5. Okay, so 3 plus minus 5. Okay, a plus and a minus become a minus. So it's w to the 3 take away 5. Okay, I'm taking away because a plus and a minus, okay, the sign becomes a minus, okay? So it's w to the power of minus 2, okay? 3 take away 5 is negative 2. So it's w to the minus 2, or you might see it written as 1 over w squared. Either way is fine, okay? These mean the same thing, w to the negative 2, okay? The next one, part B, simplify a to the 4 divided by a to the minus 2. Okay, well, I'm dividing, so I'm going to subtract the powers. Again, being very careful here, because I've got a negative there. So 4 take away negative 2. Okay, so taking away negative 2, it's same as adding 2. Okay, those two minuses change the sign to a positive, so 4 plus 2, which is a to the power of 6, okay? So it's a to the power of 6. Okay, this is question number 7, guys. Simplify 2a cubed c cubed times 3a squared c. So again, if I do the numbers times together and then the letters times together corresponding, so 2 times 3, guys, we should know is 6. A cubed times a squared, well, I'm going to add the powers here. So it's going to be a to the 5, 3 plus 2 is 5, and c cubed times c, remember that I've got a power of 1 here, is c to the 4, because 3 plus 1 is 4. Okay, so that's all I do with these ones. Okay, so it's slightly more trickier, but that's what I do. I do the numbers first, then the corresponding letters, and then the letters after that, okay, if there are any more. Next one, simplify this. Well, 10 divided by 2 is 5. M to the 5 divided by m squared, I subtract the powers. So 5 take away 2 is 3. N to the 4 divided by n. Remember, it's an invisible 1 there. Okay, is equal to n cubed. 4 take away 1 is 3. So that's my final answer. Okay. This is question number 9. Simplify 2m to the 4 all cubed. Well, I've got 2 cubed, okay, times m to the 4 all cubed, okay. Now, there's multiple ways of obviously working this out. I could write it as 2m to the 4 times 2m to the 4 times 2m to the 4. But I'm doing it this way just so you understand actually the rules of indices. So 2 to the power of 3, or 2 cubed, is 8. M to the 4, all cubed, okay, is m to the 4 times 3, which is 12. So the answer I get is 8m to the power of 12. Okay. Right, guys, this is question number 10. Simplify a to the 1/5 times a to the 2/3, all divided by a to the 3/5. Okay, so numerator wise, I'm going to add my fractions together. Okay, so it's going to be a to the 1/5 plus 2/3. So again, it's going to be revisiting our knowledge of fractions. Remember that if we add fractions with different denominators, we find a common denominator. Okay, So 1/5 plus 2/3 can be written as a fraction out of 15 because the lowest common multiple of 5 and 3 is indeed 15, which is 5 times 3. Okay. 1/5 same as 3/15, and 2/3 is same as saying 10/15. So 3/15 plus 10/15 is 13/15. Okay, so I'm going to have a to the 13/15, okay, and then I'm going to be taking away, okay, because there's division here, so 13/15 take away 3/5, okay, to work out our answer, okay. Take away, because it is a division, okay. So change this one to 9/15 by timesing the fraction top and bottom by 3. Okay. I'm going to get the answer of 4/15 because 13 take away 9 is 4. So the answer I get is a to the power of 4/15. Okay, that's my answer. Okay, this is question number 11. The square root of all this. Okay, so let's just break it down. 50 divided by 2 is 25. Pi divided by pi just end up cancelling. Okay. A to the 5 divided by a to the 3 is going to be a squared because 5 take away the 3 if I'm dividing. Okay, I subtract the powers. The square root of this gives us the answer of 5a. Because the square root of 25 is 5, because 5 times 5 is 25, and the square root of a squared is just a. Because the square root of a times the square root of a gives me the answer of a. So the square root and the square end up cancelling each other out because they're what we call inverse operations. And you can check your answer, because if I do 5a times 5a, I do indeed get 25a squared, because 5 times 5 is 25, and then a times a I can write as a squared, okay, using the laws of indices, because I've got a power of 1 here and a power of 1, adding my powers, if it's the same base, okay, is indeed a squared, okay, so that is that answer for question number 11. Okay, so I hope these last few questions made a bit of sense. Okay, any questions, any queries, put it in the comment section. This is looking at around grade 4, 5, and some of these last few questions may even be pushing to like the early signs of grade 6. Okay, particularly question 10 and 11 I would say are potentially like the early signs of like grade 6 level maths for GCSE 9 to 1 maths. Okay, right guys, so that is the end of today's video. So thank you so much for watching, thank you for making it to the end. If you like this video, please press like, please press that subscribe button if you're new to the channel, and lastly, please click that bell icon so you don't miss out on further videos and further uploads. Okay, but that's it for me today guys. Thanks for watching, take care, stay safe, and I'll see you for the next one. Bye for now.